Hey guys, today we're going to continue working on equivalent ratios. Alright, so we're still on the standard RP.1.1, that is to understand the concept of a ratio and use ratio language to describe a ratio relationship between two quantities. So our learning target today is, given a ratio, you'll be able to identify equivalent ratios. So you'll be able to use tape diagrams and the description of equivalent ratios to determine if two ratios are equivalent. Alright, so let's go ahead and look at our worksheet. It's lesson 4, equivalent ratios, and let's look at example 1. Alright, it says the morning announcement says that 2 out of every 7 6th grade students in the school have an overdue library book. Jasmine said, "That would mean 24 of us have an overdue books." Grace argued, "No way, that is way too high." How can you determine who is right? If you look at that problem, the only thing it gives us, the only important information, is that it tells us that 2 out of every 7 students in 6th grade has an overdue library book. So Jasmine said that 24 students has an overdue book. So we'd say it'd be 24 here. All right, and Grace says, "No way, that is too high." Well, how can we make it to where Jasmine is right? How many students would there need to be? First, we need to see, to make this equivalent, what do you multiply by 2 to get to 24? All right, you would need to multiply that by 12. So now to make this ratio equivalent, you need to also multiply your 7 by 12 to get to 84. So in order for Jasmine to be correct, how many students would need to be in 6th grade if 24 students had an overdue book? I'll give you a second, talk about it to your partner and in your group, and determine how many students will need to be in 6th grade for Jasmine to be correct. All right, so you should have said 108. If there's 108 students, then 24 could have an overdue library book, where 84 did not. And you could create that tape diagram. Give me just a second, I'll show you guys how you could even create this tape diagram. All right, so we'll put an O for overdue library books and just a B for books. So it's 2 to 7. So there's 2. All right, so this would have to equal 24, which means each square equals 12, and this would need to equal 84. Again, each of these blocks would equal 12. And that's how you create a tape diagram, 2 to 7, which is also equivalent to 24 to 84. All right, let's look at exercise 1. It says, decide whether or not each of the following pairs of ratios is equivalent. All right, then it says, if the ratios are not equivalent, find a ratio that is equivalent to the first ratio. If the ratios are equivalent, identify the non-zero number, C, that could be used to multiply each number of the first ratio by in order to get the numbers for the second ratio. All right, so let's look at A. It says 6 to 11, and 42 to 88. I'm going to give you guys a second to determine if these two ratios are equivalent. All right, so what do you multiply by 6 to get to 42? You multiply it by 7. Do you multiply 11 by 7 to get to 88? No. That's multiplied by 8. So you're multiplying by two different numbers, which means no, that is not, those two ratios are not equivalent. So now take a second and think about what number can we change this to make it equivalent to our first ratio. We'd only really need to change one number. So think about the 88. What can we change that 88 to make it an equivalent ratio? Alright, so you should have seen 77, because if you multiply 6 times 7, that's 42, and 11 times 7 is 77, which would give us an equivalent ratio. So in that, for A, you should have put an X or a check mark by no, and then you could have put 42 to 77 to change to make it an equivalent ratio to the first ratio. All right, let's look at part B. We have the ratios 0 to 5 and 0 to 20. All right, so take a second. This one's kind of tricky. Are these two ratios equivalent? Think about it. Are you multiplying these by the same thing? All right, well, let's go from the second number. 5 times 4 is 20. Well, 0 and 0, you were probably thinking 0 times 0, but can you multiply that by 4 as well to get 0? Yes, you can. You could multiply both of those numbers, both of these, by 4 to get over here, because 0 times any number is still going to be 0. So that actually is an equivalent ratio. So you would put yes for B, and the value of C would be 4, because 0 times 4 is 0, and 5 times 4 is 20. All right, let's move down to exercise 2. So go ahead and turn the page. All right, it says in a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. I'm gonna go ahead and write that down and underline it. It's always good to underline that important information. All right, so determine the number of walnuts that are in a bag if there are 54 cashews. Use a tape diagram to support your answer. Justify your answer by showing the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. All right, so I'm going to start you guys off by creating the tape diagram. So our first number is the walnuts, and then we had the cashews. So it's 5 to 6. So I'm going to draw a tape diagram. 5 walnuts. And then I'm going to draw a tape diagram for the cashews with 6. All right. Now I want you guys to talk to your partner or talk in your group and determine how you would find out how many walnuts there are if you know that the cashews, is equal, so that means this whole thing, all 6 of these boxes equals 54. How can you determine how much walnuts there are? Please pause the video at this time, give them a few minutes to discuss it within their groups or with their partners. Okay, so you should have seen that if there were 6 boxes for cashews, all right, 54 divided by 6 is 9.
And you may go ahead and read.
All right, so that means each one of these boxes are equal to 9. If each one of these boxes are equal to 9 with cashews, that means all the boxes for the walnuts are also equal to 9. So there's 5 boxes for walnuts that are all equal to 9. 9 times 5 is 45. So now we have, all right, so now we're going to determine, it wants us to make sure that those two ratios, we had to justify our answers, we created a tape diagram, and now I want to put 5 to 6 and show how that is equivalent to the ratio for 45 to 54. All right, so what do you multiply by 5 to get to 45? You multiply it by 9. 9 times 5 is 45. What do you multiply by 6 to get to 54? All right, so you'd also multiply that by 9. So since we multiply both sides of the ratio by 9 to get our new ratio, then that is equivalent. So we proved it with our tape diagram and by seeing that both sides are multiplied by 9. All right, so let's look at the problem set now. Number 1 on the problem set says use diagrams or the description of equivalent ratios to show that the ratios 2 to 3, 4 to 6, and 8 to 12 are equivalent. So I'm just going to start, I'm going to prove mine. I could just make a tape diagram, 2 to 3. And take a few minutes to see how you can incorporate these ratios into that initial first tape diagram to prove that they are all equivalent. Okay, so let's look at 4 to 6. Can this equal 4 and this equal 6? What would each box represent? Each one can represent 2. It's equal to 2. And then you have 2, 4, 6, and 2, 4. So we just proved that 4 to 6 is equivalent to 2 to 3. So now let's check 8 to 12. The same way, see if you can figure out what each box on the tape diagram would be if this was supposed to be 8 to 12. All right, so you should have seen that each box can equal 4. So for the top 2 boxes, each one equals 4, you'd have 8. And for these 3, you'd have 4, 8, 12. So that is I used a diagram for number 1 to show that 2 to 3, 4 to 6, and 8 to 12 are all equivalent. All right, so let's look at number 2 in the problem set. It says prove that 3 to 8 is equivalent to 12 to 32. And you could use a tape diagram, or you could just show what do you multiply each side by to get the second ratio. So 3 to 8. So let's try it this way now. Before I had to prove it with tape diagram. Now we'll see by multiplying. All right, so think about what would you multiply 3 to get to 12, and what do you multiply 8 by to get to, 32? Give you a second to think about that. All right, so you multiply 3 times 4 to get to 12, and you also multiply 8 times 4 to get to 32, and that's how they are equivalent. So just answer B using your own words about how to use the description of equivalent ratios to support your answer that you got for part A or number 1. All right, and then let's look at the last one on the problem set. It says the ratio of Isabel's money to Shane's money is 3 to 11. And we'll write that down. 3 to 11. If Isabel has $33, how much money do Shane and Isabel have together? Use diagrams to support your answer. So first you need to have a tape diagram. I'll put I for Isabel and an S for Shane. So Shane has 11. And Isabel has 3. Okay, so it says that Isabel has $33. So if these 3 boxes equal 33, what's 33 divided by 11? I'm sorry, I just gave you all the answer. 33 divided by 3, which is obviously 11. Because 11 times 3 is 33. So if those 3 boxes are worth $11, then each one of these for Shane is also worth $11. So then you just do 11, there's 11 boxes for Shane, they're all worth 11. So you do 11 times 11 to figure out how much money Shane has, and that'd be $121. So now it wants to know how much does Shane and Isabel have together. So then all we need to do is add 121 to that $33. And how much do they have together? 154. All right, good job, everybody.